Hi everybody, so this is going to be a video on right triangle trigonometry. As you will see, right triangle trigonometry and by extension non-right triangle trigonometry, it exists both for acute and obtuse triangles as well as circles, has a lot of different applications in both math class, so you will see it a lot in Algebra 2 Trig, Pre-Calculus, Calculus, and those types of situations, but you will also see it in various other fields where math is important. So physics or other sciences, navigation, for example. If you were to look at how a pilot, let's say, navigates a plane and how they decide how it should turn, where it should go, and stuff like that, trigonometry is involved in that to a great extent, and others. I'm just picking out a couple examples. So, this is something that's going to be around a while. As we saw before, in a right triangle, we know a couple things. We know that a right triangle is a triangle with one right angle. We know that a right triangle obeys the Pythagorean theorem, which says that the two legs, the two perpendicular sides, if you square them and add them, you will come up with the hypotenuse, the longest side, squared. And again, that hypotenuse is always opposite the right angle. We also know something else. We have this thing, trigonometry. Trigonometry is a series of ratios, the sine, the cosine, and tangent. They relate the lengths of the sides with the measures of the acute angles. Okay, so there's two things that I want to kind of highlight here. The first I'm literally going to highlight is acute angles, okay? So in this triangle, I can use trigonometry and apply it to angles x and z, but I cannot apply it to angle y. These rules do not work on the right angle, okay? You will use the hypotenuse, but you will never use the right angle. The second thing I wanted to talk about, of course, is the ratios, or you can also think of them as formulas. The sine, which is abbreviated as sin. Don't say sin, that's not the right terminology, okay? It's sine. We have sine of whatever, I'm going to talk about that blank in a second, is equal to the opposite side over the hypotenuse. Cosine, abbreviated COS, is the adjacent over the hypotenuse, and the tangent, abbreviated as TAN, is the opposite over the adjacent. Now, what does any of this mean? Okay, so I'm going to take away the highlighting on angle Z. We're going to do angle X, just for example. So for angle X, you would have the X goes here, okay? So we always take the sine, cosine, or tangent of an angle. It's an operation to take the sine, to take the cosine, to take the tangent, and you're taking it of an angle. So that's what is going to go in the parentheses. Sine of angle X is equal to the opposite over the hypotenuse. Well, we know where the hypotenuse is. Certainly it's here. And we can abbreviate that HYP. We know that is the hypotenuse because we know that angle Y is the right angle and ZX is the side across from that. So side ZX is the hypotenuse. And it will always be the hypotenuse. For angle X, this idea of opposite and adjacent, well, the opposite side, those are sides. The opposite side for angle X, you find it the same way you found the opposite side for the hypotenuse, the opposite side for the right angle. Straight across from it. What side is not connected to the X? Well, that would be ZY. So opposite for angle X is ZY. Okay? The adjacent side then has to be the other one, and we can abbreviate that ADJ. And we know that it is adjacent because look at the two angles Z and X. The two sides that connect to form those angles, one is the hypotenuse, but we already know what that is. It can only be one thing. It's only the hypotenuse. That 20 is only the hypotenuse. So the other side that makes the angle, we call it the adjacent side, YX. So where we see adjacent, we're going to put YX. Okay? And then, I'm going to do this on the bottom just because we have, we're kind of running out of room. So I'm going to move my little note over to the side so I have room. So I'm going to do this, continue doing this in yellow. The sine of angle X. And by the way, and I'm just doing this down here because I ran out of room because the figure is in the way. But what I would highly advise you do, and what I always say when I do this in class, is that when you write, you should really write it out. And you can use the abbreviations, but you should really write it out. Sine of angle equals opposite over hypotenuse equals, and then write what I'm about to write right here. So do that, because what you're going to see, and that'll help you if this is the first time you're seeing it, or even if you're reviewing it and you know that you have a hard time remembering it, it's going to help you memorize those relationships. It's going to help you memorize those formulas. So the opposite is ZY. ZY is 16. The hypotenuse is ZX. It's 20. For cosine, the adjacent is 12 over the hypotenuse, which is still 20. For tangent, the opposite is still 16, and the adjacent is still 12. You do have to reduce. To reduce, you would just simply do that the same way you would any other fraction. 16 and 20 are both divisible by 4, we get 4/5. 12 and 20 are both divisible by 4, we get 3/5. 16 and 12 are both divisible by 4, we get 4/3. Okay? And that's all it is. The last thing I do want to show you is there is not one sine, cosine, tangent set for a right triangle because you have two acute angles. So the one that we have in yellow and gold here is the sine, cosine, tangent for X. We also can have a sine, cosine, and tangent for angle Z. Okay, we cannot have one for angle Y because angle Y is a right angle and our rules don't work for the right angle like I said earlier. So I'm going to fill in, and I'm going to do this like I said how I would advise you to do it if you were in my class, which is to say write down the trig function, write down what the formula means, and then we're going to write down our answers. Okay, so we are doing the sine, cosine, and tangent of angle Z. Z goes in the parentheses. Okay, now for this one, the hypotenuse is still ZX, it's still 20. So you can write ZX wherever you see hypotenuse, and then you can put a 20 in the denominator. And again, if the hypotenuse is going to be used in a problem, it's always going to be the denominator. Okay. For opposite now, the opposite for Z is the side that's across from Z. So it's not YZ anymore, it's YX. So I'm going to write opposite in blue. So for the blue angle Z, the opposite is 12. And that was side YX. Okay. And then for adjacent, it's what's connecting to Z, but is not the hypotenuse. Well, that's this one, ZY. So I'm going to write that. ZY is the adjacent, and that's 16. And then just as before, we have to reduce. So this would be 3/5. This would be 4/5. and this would be 3/4. Okay, so, and again, you should notice here that the sine and cosine switch when you switch angles because the opposite and adjacent switched, right? What was the opposite for angle X is the adjacent for angle Z. The tangent is reciprocal because opposite and adjacent changed, okay? And again, labeling, I know this looks a little messy. Some of you might be a little nervous because of that, but it does matter. The labeling, the highlighting is, the writing of the formula is extremely helpful. Okay? So let's do just some very targeted practice here. They would like us to find the sine of angle Z. Okay? I know that the sine of an angle, write that formula down. It's the opposite side over the hypotenuse. Okay, well, we know the hypotenuse is the easiest to find. Look for the right angle, go straight across from it. The hypotenuse in this case is ZX 37. We need the opposite side. Opposite angle Z is straight across from the Z, which is the 12. So your sine for angle Z is opposite 12 over hypotenuse 37. No reducing because there are no common factors. 37 is a prime number. Right? Okay, you try to find the cosine of angle C. So pause this, try the problem, hit play when you're ready. Alright, and the answer is 4/5. Please make sure that if you left it as 40 over 50, you remember to reduce. These are still fractions. They still follow the same rules as we do for all fractions. Okay. So we know that C is our angle. We know that cosine is adjacent over hypotenuse. The hypotenuse is 50, right across from the right angle. The adjacent is the side that connects to C that is not the hypotenuse, which is BC, which is 40. The cosine is 4/5. Now you might be saying, well, I've seen 4/5 before in this video. Yes, you are correct. We saw in the sample problem that I did that the cosine of angle Z in the sample problem was 4/5. But what does that mean? One has sides 12, 16, 20, and one has sides 30, 40, 50. What does that mean? It simply means this. Angle Z in our original problem that I did when I was explaining what sine, cosine, tangent were, and angle C in this problem are the same number of degrees. They're the same angle. What? Remember when I said taking the sine, the cosine, the tangent of an angle is an operation, okay? We have a rule in math, in algebra. I know this is geometry, but think about algebra for a second. If I do an operation on the same number, I should get the same answer no matter how many times I do that operation, right? If I add 2 plus 2, I'm only ever going to get 4, right? If I do maybe something a little bit more like this. If I do 5 to the second power, no matter how many times and how many ways I calculate 5 to the second power, it's always 25. No matter how many times I take cosine of whatever this angle measurement is, I will get 4/5. Okay, we'll actually talk about later how to figure out what that angle value is. But that is the fact. Because that is the only possible value for cosine of whatever those degrees are, that is the only answer that you can get. All right, one more practice. All right, tangent of C, pause, and then play again when you're ready to check your answer. And the answer is 3/4. Again, if you left 27 over 36, remember to reduce. Tangent is opposite over adjacent. 27 is opposite. 36 is adjacent because it's next to C, but it is not the hypotenuse. We put that together and we get 3/4. Again, that's the same as tangent of Z from the sample problem at the beginning, because again, C and Z in both of these examples, actually all three of the examples, are the same angle. All right? Now, we can go backwards. So, like I said before, taking the sine, cosine, tangent of an angle is a mathematical operation. Every mathematical operation that we do has an opposite, right? We call that the inverse operation. So, things that we know from Algebra 1, even back to pre-algebra. Addition has an inverse, we call it subtraction. Multiplication has an inverse, we call it division. The square, the second power, has an inverse. We call it the square root. Okay? The same is true for trigonometry. So we have, quite simply, it's actually a very simple phrase. If we have the operation sine, its inverse is quite literally inverse sine, or sometimes you'll hear people say sine inverse. Okay? Cosine has the inverse, inverse cosine. You get the idea. So, if we know the sides of it, what this means is if we know the sides of a triangle, we can use that to find the angles. If we know that the sine, cosine, or tangent of some angle is a particular number, we can then find the angle. Okay. The logic here is clear, and there's the format. If sine, I'm going to explain what that symbol is in a second, equals x, then the inverse sine of x equals the angle. This little egg-looking symbol is a Greek letter called theta, and that means angle. You will see that in all of the rest of math, where you see angles being used for trigonometry. In geometry, we usually just use the letter name, right? So sine of A, sine of B, sine of C. But you should be familiar with that symbol because you will use it post-geometry. Okay? So again, that says sine of angle, so sine of theta, which is an angle. So sine of angle equals x, then the inverse sine of x equals the angle. An example that you will see quite often, it's one of the easiest ones to remember. Sine of 30 degrees is 1/2. So I know that. So if I hand you 1/2, you can do the inverse sine and get 30. This notation, this -1 exponent, means inverse sine. And so if you have cosine, it would be cos -1 put in the value. So if we take the inverse sine, the inverse cosine, the inverse tangent of a number, we should get the angle. There are several rules that you should know in geometry. Sine is always going to be less than 1. Okay? Cosine is always going to be less than 1. Okay? Tangent can pretty much be anything. So it can be a fraction less than 1, like 3/4, like we saw earlier. It can be things greater than 1, like 4/3 that we saw earlier. If you try to do sine of 4/3, sine inverse of 4/3, you're going to get an error message. It's not going to work correctly. Okay? And we're going to look at how to do this on the calculator right now. So I'm going to just make my calculator screen a little bit smaller so you can see it in the window. Okay, so there's two things I want you to do. First, if you have a calculator like this one, so a graphing calculator, you have a button here that says mode. You want to click it. Now I have an older calculator, a TI-83. Many of you will probably be using a TI-84 or newer. So it might look a little different. You might have a few more options, but what I'm going to go through with you right now will be there. Okay? Couple lines down, you see this line, radian and degree, where my cursor is blinking right now. Radians are a way to measure angles you will use in higher level math. In geometry, we use degrees. You want to make sure whenever you're going to do trigonometry with your calculator, that degree is what you're working in. If you're working in radians, nothing you put in is going to be useful. It's all going to be wrong. So again, how do I get there? Press the mode button. Use the down arrow to get to the line where you see radian and degrees. Use the right arrow to highlight degree. Hit enter. You'll see how degree is highlighted now. Now that means I'm in degree mode, so I can put in and do operations with angles and degrees without a problem. Press second and mode to go back to the main screen where we can do some math. To get inverse, you're going to do second and the trig function you wanted. So we want inverse sine. You're going to click sine, put in your angle 30 and hit enter. Now I did it wrong. How do you know I did it wrong? Because I got an error message. What did I do wrong? Well, I put 30 in sine inverse, and this is a common mistake. But what did I tell you? Sine must be less than 1. If you put a number bigger than 1 inside sine inverse, it's going to return an error message. I know I did the wrong thing. All right, so let's do it correctly. We want to find sine inverse of 1/2, so you can use the decimal or the fraction version of that. Remember, on this, to do a fraction, you have to do numerator divide by denominator, so this would be, if you wanted to put a fraction instead of 0.5, you'd do 1 divided by 2. And then it comes up exactly the statement that we wanted. Sine 1 negative 1, so inverse sine of 1/2 equals 30. Now, again, if you wanted to do just regular sine, and you would put in your 30, get in the habit of closing parentheses and hit enter, you get 1/2. And again, to take the sine can take any number. You can put in any number and it'll find the sine of an angle with that many degrees in it. It's the result. The result will always be less than 1. Okay? Just to tell you this, you will find in certain places angles bigger than 90. You will find sine being negative, but that's not going to show up in right triangle trig, so I'm not going to discuss that in this video. Okay? All right, so let's do some. All right, so here it says find the given measure. So we're looking for the question mark angle, and we've been given sides 37 and 32. All right, I'm just going to call this angle A. So for angle A, first we need to figure out what these two sides are. Well, I see a clearly marked right angle. I have to have this, or else I can't use right triangle trig. Okay? It doesn't matter if I'm being asked to find sine, cosine, tangent, or use their inverses to find an angle. If I don't know I'm in a right triangle, those tools don't apply. So across from the right angle is 37. That makes it hypotenuse. 32 is across from angle A, not attached to it. That makes it the opposite angle. And I know that the sine of an angle is opposite over hypotenuse. So that means, and I'm going to go through the steps as if it was algebra with you. So the sine of angle A is the opposite side 32 over the hypotenuse 37. Now the operation of inverse, I'm going to take sine inverse of each side. Remember, an operation and its own inverse cancel. So on the left, I am left just with angle A. And then on the right, I'm going to need the calculator. Second sine, so sine inverse, 32 divided by 37. And I get 59.867. Now, for rounding, many times we will round this up to 60 degrees. Now, some people have an issue with that because that would make this a 30, 60, 90 right triangle, and you'll notice it doesn't obey the rules, right? If it was a 30, 60, 90, we would have 30, we would have this angle A, the opposite side being something root 3. So some people will have a problem with that. I understand that. So some people would prefer to leave that as like 59.87 or 59.9. Just be aware, most of the time though, when you're being asked to find angle measurements, it will say to the nearest whole degree. And that's kind of a math class convention more than anything else. All right, pause this one to do practice. Hit play when you're ready. And the answer is about 17.75, which we can round up to 18 degrees. I called the mystery angle angle A again. 21 is across from the right angle, so it's hypotenuse. And 20 connects to angle A as well, so it is the adjacent. So we know that adjacent and hypotenuse make cosine. So cosine of A is adjacent 20 over hypotenuse 21. I did the inverse because I'm looking for the angle measure. And then that gave me the 17.75, and I rounded. All right. Last one. So this one I'll do with you. We'll call this angle A again. So we don't have a hypotenuse this time, because the hypotenuse would be here at the blank side. Every once in a while when I do this in class, I'll get the question, can I use the Pythagorean theorem to find the hypotenuse? Yes, you can. And then use sine or cosine. But you don't have to do that, because remember, we have tangent. So we know the tangent is the only one of the trig functions, the trig ratios, that does not use the hypotenuse. It's defined by opposite side over adjacent side. Okay, so the tangent of angle A in this case, and again, you could use whatever letter you want, I just use A just because it's easy. I need to find the opposite side. Well, the opposite side is always the one straight across from it. So opposite here is 2. Adjacent is the one next to it that is not the hypotenuse, which is right here, which is 3. So the tangent of angle A is 2/3. To find angle A, we do tangent inverse of 2/3. And by the way, you might be wondering why I'm not doing tangent inverse on both sides and crossing out anymore. That's just because it's okay now to assume when you see this, just do the tangent inverse in your head and make that tangent go away. So it's perfectly fine now to write angle equals tangent inverse of the fraction. Okay, so it'd be tangent inverse of 2/3, and I get, tangent inverse, I didn't pull the right thing there, would be 33.69, and then we can round that up to approximately 34 degrees. Okay, so that's trigonometry. So the 3 formulas that we learned, the sine is the opposite over hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over adjacent. Hypotenuse is always in a fixed location in a right triangle across from the right angle. Opposite and adjacent depend on which one of the 2 acute angles you're using. These rules do not apply to the right angle. So knowing that, we can find the sine, cosine, or tangent of an angle. We can also find the measurement of the angle itself if we know the sides, as we did here, by employing the inverse trig function, inverse sine, inverse cosine, or inverse tangent. All right? Thank you for watching.